All right, let's just jump right in with a scenario that honestly should keep every cloud architect up at night. Imagine this: an entire Azure region, West US, North Europe, doesn't matter which, just goes dark. It's offline. Is your app still running? Or is it just game over?
Look, here's the thing. Stuff breaks. Downtime is going to happen. It's inevitable. We can't build systems that never, ever fail. It's just not possible. But what we can do is build systems that can survive a failure. And that survival isn't about luck. It's about a very deliberate design choice. And that choice really boils down to two key strategies: high availability and disaster recovery. So first up, let's talk about high availability, or HA for short. Now, the best way I've ever heard this described is to think of it as your car's automated spare tire, right? You get a flat on the highway, you don't need some massive, complicated plan. You just pull over, the spare kicks in, and you're back on your way in a few minutes. It's a quick, local fix for a quick, local problem. And that is the absolute key difference. High availability is not about recovering from downtime. Its entire job is to prevent it from ever happening in the first place. It works within a single geographic region, automatically handling those smaller, more common failures. A single server dies, a storage rack goes offline, maybe even an entire data center in an availability zone. It's all designed for seamless, automatic continuity. So how do you actually do this in Azure? Well, it all starts with deploying your application across multiple availability zones, which are basically just separate, isolated data centers inside the same region. Then you use services like zone redundant storage, so your data is automatically copied across all those zones. And the real MVP here is the Azure Load Balancer. It's like the traffic cop, constantly checking the health of your app. And if it sees any trouble, it just automatically routes users away from it. It's an active, always-on defense. Okay, now let's shift gears and talk about disaster recovery, or DR. If HA is your spare tire, then DR is your standby second car sitting back at home in the garage. Your main car doesn't just have a flat tire anymore, it's been totaled in a major accident. You're not fixing this on the side of the road. You gotta make a call, get a ride home, and get the other car. It takes way more time, way more coordination, but it's what gets you going again after a real catastrophe.
And this is a totally different mindset, right? DR is a process to recover after the disaster has already happened. This is what you turn to when your entire primary region is gone. At this point, the goal isn't to prevent downtime anymore. That ship has sailed. The mission is now simply to get your application back online in a completely different region within an acceptable time frame.
And as you'd expect, the toolkit for DR looks very different. Now you're using heavy hitters like Azure Site Recovery to replicate and fail over entire applications. Your data is being copied hundreds, maybe thousands of miles away using geo-redundant storage. And a global service like Azure Front Door or Traffic Manager is what's going to actually redirect all of your users to that backup region when you officially declare a disaster. So let's just put them side by side, because this really clears things up. First, scope. HA is local. It's all happening within one region. DR, on the other hand, is regional. It's all about going across regions. Then the goal. HA is trying to prevent downtime, while DR is trying to recover from it. That directly impacts your recovery times, right? With HA, we're talking about seconds, maybe minutes of impact. With DR, you're looking at minutes to hours. And finally, activation. This one's huge. HA is totally automated. It just happens. But DR, that's an orchestrated process. It's a big red button that someone has to deliberately decide to push. Okay, that's enough theory. Let's make this real. Let's run a little fire drill, a tale of two very different failures, just to see how these two strategies actually play out in the real world. First up, let's take a pretty common scenario. An entire availability zone inside your primary region just goes dark. Could be a network switch failure, a localized power outage, who knows? What happens next? Well, if you designed your system for high availability, honestly, it's almost a non-event. It's kind of boring in the best possible way. The instant that zone goes down, the health probes on your load balancers see it. And immediately, all traffic is automatically rerouted to your instances running in the other two healthy zones. And your users, they notice absolutely nothing. To them, the service was always on. That is high availability doing its job perfectly. So yeah, for these local failures, HA is the hero. It handles all the common bumps in the road automatically. But, and this is a big but, HA has a boundary. It has a limit. So what happens when the problem is bigger than just one zone? What if the entire region goes down?
Now for the big one. Scenario 2. Your entire primary region is offline. A major flood, a massive fiber cut, a truly catastrophic event. That beautiful multi-zone HA setup we just talked about, well, it's completely gone too because all of its pieces were inside that one failed region.
This is when you pull the fire alarm. This is where your disaster recovery plan kicks into gear. And remember, it is not automatic. You, your team, your business, you have to make the call to declare a disaster. That decision triggers the failover plan, the one you've hopefully practiced. Your global traffic service starts sending all users to the secondary region. Your replicated data is promoted to be the new live primary data, and after some recovery time, your application comes back online. It wasn't instant, but it's what saves your business.
So what does this all mean? What's the architect's blueprint for designing a system that's truly resilient? Well, the most important thing to realize is that it's not about choosing HA or DR. It's about how you intelligently layer them together. And if you remember one thing from all of this, let it be this. HA is not DR. They are not interchangeable. They solve different problems at completely different scales. Think of it this way. HA handles the frequent, smaller failures. DR is your big insurance policy for those rare but catastrophic events. They are two essential, complementary layers, and you absolutely need both.
This kind of thinking has to be baked into your architecture from day one. You have to assume things will fail. You have to hunt down and eliminate every single point of failure. You layer your defenses. Use HA for the local stuff, DR for the regional disasters. And maybe the most important principle of all, you have to test this stuff relentlessly. Because an untested DR plan isn't a strategy, it's just a prayer. And hope is not a strategy.
And that really brings us to the final critical question. It's not enough to design these systems on a whiteboard. You can have the most beautiful architecture diagrams in the world, but if you've never actually tried to fail it over, you don't really know if you have it. So I'll leave you with this one thought. You've got HA, you've got DR, but when was the last time you actually tested it?